Okay, again, so we are going to start the second of 3 talks this afternoon. I want to welcome you to the Chemistry Senior Experience talk. For the new people in the audience, as a reminder, if you're interested in coming to the chemistry picnic, sign up outside of the stockroom downstairs. And that, I guess I don't have to mention the seniors because it's the same seniors that are here. Anyhow, also want to mention that we have one more talk this afternoon. Brianna Windra is going to be talking about illuminated manuscripts at 4:45 after Leanne's talk. And then we have Romero talking on Friday at 4:30 in this room. And then next week, it is fun-filled with multiple talks. Also want to point out that all of these are now available on YouTube. Okay, so as the talks are being done, Melissa's is going up on YouTube even as we speak. So you will be able to watch them multiple times over, friends, family, etc. Okay, without further ado, I'm here to introduce Leanne King. Leanne's from Tempe, Arizona, and it's been a pleasure having her in biochem. Always challenging, and she challenges me right back. That was always a fun part of biochem too. I was just thinking about that today when we were talking about aging. Anyhow, Leanne is graduating, as we know, and she's going to be starting her own nonprofit, getting foster kids involved in soccer. So without further ado, I'll turn it over to Leanne.
All right, so I'm going to be talking about the effects of concussion, specifically impaired cognition and slowed processing. So what is a concussion? A concussion is also known as a mild traumatic brain injury. And it's called mild because normally it's not life-threatening, but it is still a brain injury and should be taken seriously. It's the most common brain injury. It accounts for about 20 or 80% of all traumatic brain injuries that occur. And it's the result of a blow or jolt to the head that disrupts the normal function of the brain. And so the brain gets pushed into the skull by that force, and it also initiates something called the Neurochemical Cascade, which we'll talk about a little later. And any concussion can result in permanent neurological impairment. And so, has anybody had a concussion? Yeah, okay. Well, okay, so the next slide is a video of me getting a concussion that I got about 250 days ago during a soccer game, and it's a little hard. I don't know. It might be a little hard to watch. So if you're squeamish or have a sensitive stomach, it's not. There's like no blood, you know, and it's very blurry. But just a warning. Okay. So yeah, about 200 days ago, I just hit my head super hard on the ground, and the immediate effects of a concussion we're seeing. And I actually don't have any memory of this game or the 2 weeks that I was on campus. It's just gone. And so you have to hit your head pretty hard to get a concussion, and it's hypothesized or something that it's about 80 Gs. And so what is a G-force? A G-force is a unit of force equal to the force exerted by gravity, and it's used to indicate the force under which a body is subjected when it is accelerated. So numbers larger than 1 indicate how many times more force was used in comparison to Earth's acceleration. So, all right. So here, a concussion is about 80 Gs, although the average concussion is 95 Gs, and so that means it's 80 times more, the force 80 times more than the force of gravity. And so here's some other comparisons, like a car crash at 40 miles per hour is 35 Gs. So it's significantly more than a lot of things. All right. So after you hit your head, what are some common symptoms? You have headaches and neck pain. I had loss of balance right away. Nausea, sensitivity to light and noise, blurred vision, mood and personality changes, changes in sleep patterns, fatigue, and what I'm most interested in, impaired cognition and slowed processing. And you don't have to have all of these symptoms to be diagnosed with a concussion. And A lot of these symptoms can last for days or like for me, a very long time. And a lot of it can be mitigated with medication and therapy. So I had to leave fall term, and I went home and got treatment and went through occupational therapy and physical therapy for about 3 months to come back to school. But the thing that has stuck with me for the longest time is impaired cognition and slow processing. And so impaired cognition includes problems with attention, concentration, language, learning, and memory. And slowed processing is just, it takes me a lot longer to take in information and process it. And so you can kind of think about how it might affect you as a student and as like a person. So sometimes it takes me a lot longer to learn things in class. And at the dinner table, sometimes I have to ask my friends, who are always really good about it, if I've told a story before, or because if we're sitting there for an hour or so, I'll try and say the same story like 2 or 3 times, since I just have to ask if I said it before, because I just don't have that memory. So there are some pathophysiological reasons for impaired cognition and slow processing, and one of them is oxidative stress, which includes too much calcium ion and dysfunctional mitochondria. There's impaired neurotransmission, including glutamate exotoxicity, which is the buildup of glutamate in a neuron, and mild axonal injury and white matter damage, and that includes axon shearing, which is from the force of the blow, and then axon swelling, which is more of the chemical ramifications of what happens after the blow. And all of these are interrelated, and so it's really hard to say, like, okay, it's all because of the axon shearing that you're having these symptoms. As we'll go through the talk, it'll become more obvious, I think, that they're all interrelated. And so I'll be starting with mild axonal injury and white matter damage. So in normal neuron function, what happens is a signal arrives at the dendrites of a neuron, and that signal will travel down the axon to another cell through an action potential and depolarization, and then it'll reach the axon terminal where neurotransmitters will be released. So this is what happens, or should happen, in a normal, healthy brain. But sometimes when you get a concussion, and it doesn't happen for all concussions, but you have diffuse axonal injury, and so it's actually a shearing of the axons that's caused by the force of when you get hit. The brain tissue sliding over each other will cause axons to shear, and if it tears completely, then you just lost a neuron, which is never good. But sometimes it doesn't tear completely, and you'll just have a little break in an axon, and that'll cause axonal swelling, and that's where the axonal transport will continue up until a point of the break, at which point the products will begin to build up and cause a swelling, kind of like with a car crash on a highway, and all of the cars have to wait and slow down. But that swelling can tear the axon at that point of break, and this is the easiest way to indicate axonal injury. And so here's a picture of an axon that is swollen from diffuse axonal injury. And so this causes a loss of synaptic terminal function, meaning that normal neurotransmission can't occur. And you can see this a lot in the white matter of your brain, and that's because white matter is mostly made up of axons that connect different parts of the brain. And so damage to the axons in the white matter essentially cuts off all communications within your brain. And an easy way to measure this is using something called fractional anisotropy, and that's used to determine the disruption of water in your brain, water flow in your brain. And it's just a good way to measure the connectivity of your brain. And so the lower the fractional anisotropy number is, there's more, it indicates that you'll have axonal injury because there's just more stuff that you have to get through. and then the higher number is more indicative of neuron degeneration because there's nothing in the way, and the water will just flow right through. And so it's a scale from 0 to 1, if people are interested in that. And so there are low FA numbers found in patients with concussions, although this is kind of new information, and so there's a lot of fluctuation and talk about whether FA numbers are even good at measuring white matter damage. Okay, so how does this relate to impaired cognition and slowed processing? Okay, so any disruption to axons impedes connections between neurons, and normally when neurons have damage, they don't regenerate, but there's a study that came out in March that showed that plants can have some regeneration of axons, but I don't think that they're not neurons, so I don't know if it'll translate over to brain cells, but there might be some hope for that. And axonal injury affects the connection in your brain, especially white matter, and white matter damage is related to slowed processing. Actually, lobotomies were really effective because they broke up all of the white matter in your brain, and so you can, the body, yeah, okay. But if the action potential doesn't go down the axon, then the neurotransmitters will get stuck and the message doesn't get sent. So there's no neurotransmission, which is a process we'll talk about in a couple of slides. And so we just talked about mild axonal injury and white matter damage, and now we're moving on to impaired neurotransmission, focusing on glutamate exotoxicity. Okay, so again, in normal neurons, in normal healthy neurons, the signal will arrive at the dendrites of a neuron, travel down the axon to another cell, where it'll release neurotransmitters from the axon terminals. All right, so how it does this is something called, is a process called action potentials, and it's a way that the neurons talk to each other. So the signal will travel down the axon through depolarization, which means that you'll see that on the video. So normally in resting potential, there's a negative charge inside and a positive charge outside, and so depolarization is just the increase of, in a brief space, inside the axon, and to make it more positive inside and negative outside. And it does this using the sodium-potassium pump, and those are on the axons, and these are the things that create the potential difference needed for action potentials. And they use ATP to pump sodium ions from low concentration to high concentration, and so I just really want to emphasize that these are important for creating action potentials, and that they use ATP. And they also restore the neuron after an action potential is set. And so, again, after the action potential reaches down the axon, it'll release neurotransmitters. And here are some hand-drawn pictures to show that I am not an art major. Okay, so here's the presynaptic neuron, where the neurotransmitters that will be sent are packaged into vesicles, and then we'll cross this gap called the synaptic cleft to bind onto receptors on the postsynaptic neuron. And so the neurotransmitters are manufactured by the neuron and stored in vesicles at the axon terminal right here. And so what happens is when an action potential reaches the axon terminal, which is this squiggly line, it'll cause the vesicles to bind to the presynaptic neuron. And then the neurotransmitters will diffuse across the cleft and bind on to receptors on the postsynaptic cell. And then these activated neurons, or activated receptors, will cause a change in the activity of the postsynaptic neuron. And something that happens right after you get hit is something called the neurochemical cascade. And so on the x-axis, you have the time in days, and on the y-axis, you have the percent change of all of these things relative to normal concentrations. And so, almost immediately what happens is there's a decrease of potassium, a decrease of cerebral blood flow, a decrease of glucose, an increase of calcium ions, and a short increase in glutamate. And the brief increase in glutamate has a lot of damaging effects to the rest of the cell. And I just want to talk about glutamate as a neurotransmitter, because it's also like in food as a food additive in MSG and other things. But here it's a neurotransmitter, and it's the primary excitatory neurotransmitter, and that just means that it stimulates the neuron to fire an action potential. And the release of glutamate at normal concentrations increases the amount of neuronal activity. It's also involved in learning and memory, and is implicated in neurodegenerative diseases like Alzheimer's and Parkinson's disease. So in the neurochemical cascade is something that I call the excitatory cycle, and this is when there's a large influx of glutamate right after the impact that we just saw on the picture, that causes a rapid and large depolarization of the neurons. And then the depolarization of the neuron opens ionic channels like the sodium-potassium pump, which disrupts cell membrane potential. And so the potassium will flow out of the cell and calcium flows into the cell. And the sodium-potassium pump uses a lot of ATP to restore this ionic gradient. And the increased, so it uses, there's more glucose metabolism to create the ATP. So glutamate exotoxicity happens when there's no sugar and no oxygen in the brain, and so then there's no ATP. And that causes all of the ATP-dependent pumps to fail, which causes a depolarization of the neuron. And this allows calcium to enter the presynaptic neuron, and calcium triggers the vesicles to bind to the presynaptic membrane and release glutamate. And then calcium enters the postsynaptic neuron and generates free radicals. And that leads to cell death, neurons dying. And so this relates to impaired cognition and slow processing, because exotoxicity can lead to downregulation and desensitization of receptors. And so downregulation is your cell's way of attempting to get the normal amount of a neurotransmitter into the body, and so it'll remove some of the receptors on the cell when there's too much stimulation. But then after the stimulation is gone, is something called desensitization, and that's just when there's a diminished response of in the presence of a neurotransmitter, because there are less receptors, and so you have to produce more of that neurotransmitter to get the same effect. And these things are also seen in alcoholism and addiction. And glutamate exotoxicity allows too much calcium to enter the cell and leads to cell death, which negatively affects cognition. And so the last thing that I'm going to be talking about is oxidative stress, which is too much calcium which can include too much calcium and dysfunctional mitochondria. So oxidative stress is an excess of free radicals, which I'll talk about on the next slide. And it can alter neurotransmission and damage proteins and damage DNA. So free radicals are molecules that are missing an electron on its outer valence shell, and it makes that molecule unstable. And so it wants to be full. And so what happens is it'll take a electron from a healthy cell, or healthy molecule as its own, to fill the shell, and then that causes the molecule that just had its electron stolen to steal another one. And so it just keeps going in a domino-like effect. And free radicals are produced naturally. They're generated through creating ATP, which is energy for our cells, and this occurs in the mitochondria. And so cellular respiration and mitochondria. So cellular respiration is the process of breaking sugar into a form that the cell can use as energy. And again, this occurs in the mitochondrion, and it's the most efficient way of producing energy. And in normal, healthy neurons, cellular respiration is really efficient at making ATP. And your brain uses, it's like 60% of all of the glucose that you consume. So it's really important for the brain to have glucose, especially because that glucose is used to help operate the sodium-potassium pumps that are so necessary for action potentials to be sent. But what happens after a concussion is that there's no oxygen in the brain, and so it'll go through a different process. So as a result of the neurochemical cascade, there's less blood flow in the brain, which means that there's less oxygen being brought to the brain, which is something that's needed for normal cellular respiration. And there's also a decrease of glucose, which means that there's less ATP, and that adds to the ATP deficit. But if you remember from a couple slides ago, those sodium-potassium pumps are working really hard to fix the imbalance that occurs after the glutamate exotoxicity. So there's more ATP consumption than production, and so there's a deficit in that. And this ATP deficit leads to a buildup of calcium in the mitochondria, and mitochondria don't really like a lot of calcium in them, and so it'll overexcite it and cause oxidative stress. And there's also increased glycolysis, which is our body's way of creating energy when there's without the presence of oxygen. And it also creates lactic acid, which I think everybody who's ever had to run a mile for PE knows what lactic acid feels like. It's not good, unless you like it, I don't know. But it affects the cellular pH and causes something called acidosis and damages the cell wall, and it can lead to cell death. So this relates to impaired cognition and slow processing because the influx of calcium and oxidative stress really gums up the mitochondrial function. And it's important, or the mitochondria is important because it's the site of cellular respiration. So if it's busy trying to figure out how to get rid of the calcium and how to get rid of the oxidative stress, then it's not making as much ATP. And less ATP can lead to cell death. And this is also implicated in the same neurodegenerative diseases as before. And so concussion recovery. So the recovery time is highly variable. For some of the people, like Sarah, had a concussion about the same, like 2 days after my concussion. She's healed and is fine, but I still am struggling with a lot of things. And I've been told by my doctors that the symptoms that persist for more than a year are more likely to be permanent, and so that's kind of a hard pill to swallow. And any concussion can result in permanent neurological impairment, but not all concussions will lead to it. And that's just because there's a lot of neuron death. Post-concussion syndrome is part of, there's not like a really good definition of it, but it's just the continuation of symptoms after, I think it's 2 weeks. So anybody who has headaches after 2 weeks is technically diagnosed with a post-concussion syndrome. And then there's two things called the second impact syndrome and chronic traumatic encephalopathy. it's a hard word to say. And these things are in the news a lot. So the first one, second impact syndrome, is when you get hit or you get another concussion within like 3 or 4 days of your last concussion, and your brain just can't handle that stress, and it'll just shut down and you'll die. But it's really uncommon, especially now, because for athletes, there's protocols that we have to follow to get back into play, and I think that has helped a lot in reducing those numbers. And then chronic traumatic CTE, I'm just going to say CTE, it's caused by chronic concussions over a large period of time, and you see this a lot in the NFL, and a lot of people have been talking about this lately because it's just so prevalent, and it can result in neurodegeneration on its own. And then there are also potential drugs that supposedly mitigate impaired cognition and slow processing, but I think people just think that they're going to work because similar symptoms in concussions are similar symptoms in these neurodegenerative diseases, and so they think it might work. So those would be donepezil and amantadine. I think it's all speculative right now, and it's more of a hope that these drugs would work than fact. Okay, so the combination of axonal injury, impaired neurotransmission, and oxidative stress contribute to post-concussive cognitive deficits. And part of it is caused by the neurochemical cascade that occurs quickly after you get hit. But also the hit itself can cause a lot of damage to the axons and white matter in your brain. And each concussion is unique and is affected by factors like the location of the injury. I just read this. It's actually better if you get hit straight on or from the back of the head, because your brain will just move back and forth linearly. But if you get hit on the side, it'll cause rotation of the brain, and it's more likely that the diffuse axonal injury will occur because it's just more of a stretch. And history of previous concussions can affect it. Your age can affect it too, and your gender. So there's been an increase of female athletes having concussions, especially in high school, and it's been hypothesized that it's because our women's necks aren't as strong as men's, and so we're just more likely to have it flop back and hit it than men's, which I don't know if that's true, but that's hypothesized. And it also might increase the likelihood of developing neurodegenerative diseases, which is kind of a bummer for me. But yeah, that's all I have. Questions? If people are interested, so my father calculated the supposed amount of G-force that happened to me. And he said that I was 4 feet tall, which I am not 4 feet. I just want to make that clear. But he gets 81 Gs from a quick calculation. So, all right, questions? Sarah.
I know that you're kind of taking a bit of a different route after Lawrence, but do you think that this is ever an area of research that you would maybe want to get back into?
Yeah, maybe. I just I want to take a break from academics, and especially now that I can't really be a very good student. It takes me a lot longer to do things. I want to see if my brain can heal first, and then get back maybe to it. answer?
Yes.
Brighton?
With like the children that you plan on working with after college, is there going to be any difference in like the way that you work with them because of how serious you've had your concussion?
Kind of. I mean, I'm hoping that they're not gonna like nail me with a ball in the head, so that's one thing. But the U.S. Soccer just came out with new guidelines like a couple of months ago that says that we can't teach kids under 12 or 14 how to head the ball because of concussions, and so I have to follow that protocol and those guidelines set up. So, and the kids that I'm working with are 10 to 12, and so I can't be teaching, I won't be doing heading to them. Olivia?
So, you talked about the SIS thing, but what about if it's not like within a few days of each other, but having concussions, like having had, because you've had past concussions. So did you find anything about if that affects later concussions, or is there not really much?
It's hard to tell. There's not like any conclusive research on it, and it's a lot of like kind of guessing about it. Sarah?
Yeah, I was just wondering, I thought it was really cool how you were saying that there was a study with the plants
Yeah.
and how they can regenerate.
Yeah.
Just maybe, do you know anything else about that?
No, I just no. But I can read I guess I can read the paper and not just the abstract, the concluding section. But yeah, I just thought that was really cool that for a long time it was just like that's it for cells, but
Were they specifically thinking of using that in like concussion applications, or is that just something that you thought?
that's just something that I
Yeah.
thought might work. Hopefully.
Maybe you'll do it.
I don't know. We'll see. Anything else?
Are there other metals besides calcium involved in this cascade and this creation of free radicals?
Sorry. I don't think so. Well, maybe, but not to the extent that calcium and potassium are. Because I think calcium was like, hold on, I'll go back to it. Maybe. All right. Yeah, calcium increases to 500% times normal. Yeah, it was really interesting to learn about all of this stuff because your doctors, I don't know if anybody's had a concussion, but and had to go to a doctor that's on campus, but they don't really tell you anything except that you have a concussion and that it's going to take a while and that it might be longer than 2 weeks to heal. And so it was really interesting to learn about